Welcome to Student Energy Photo Chapter's first webinar. My name is Wong Promise, the President of Student Energy Photo Chapter. Hope you all are doing great and staying safe. Thank you for joining with us today. Before we continue, I would like to list out some house rules to help us have a seamless webinar. So one of the house rules we have is always mute your mic unless you want to speak. Use the Q&A chat box to ask questions. Then raise your hand when you want to speak. So Sachiko, the section will run like this. You will give us a brief description about the project. Then we'll ask you questions. We'll have a Q&A section where we'll ask you questions and you answer, give us the best answer. So today, let me start my screen sharing. So today is our first webinar and it's tagged a discussion with Sachiko grabbing Nigeria's first Undergrid Minigrid system. So Sachiko Grabber is a senior associate with Rocky Mountain Institute. Rocky Mountain Institute is an organization in the United States dedicated to research, publication, consulting, and lecturing in the general field of sustainability, with a special focus on profitable innovation for energy and resource efficiency. Once again, welcome, Sachiko.
Thanks, Thomas. Is it okay for me to just jump in with a bit of an introduction here, or how do you want to do it?
I will introduce you, but I want to welcome you for the second time.
Thanks very much.
So let's have a brief description of Student Energy Photo Chapter. Sorry, hold on a bit. So Student Energy at the Federal University of Technology is an inspiring, inculcating and bringing together like-minded students from different disciplines such as engineering, science, and business who are passionate about energy sustainability, challenges, sources, transition, and climate change, which will be accomplished through creating awareness by community outreach, collaborative education, meaningful discussion, workshop, speaker series like the one we are having now, and networking events in Federal University of Technology, Owerri, Futo, and its community. So, Sachi is a former senior associate with Rocky Mountain Institute, working with the African Energy Program. Sachi's work with the African Energy team currently focus on off-grid development in Nigeria, where she is helping to identify and expand opportunity for off-grid electricity system through market analysis, holistic energy planning, Minigrid system modeling, and project implementation. Prior to joining Rocky Mountain Institute in 2017, Sachi gained experience in energy systems and sustainable development through her education and experience as Peace Corps volunteer. Her academic research has focused on rural renewable energy systems and developments, including publication of solar mini-grid policy and implementation in Pradesh, India. So Sachi, you can now go ahead and give us a brief description about the first Undergrid mini-grid project in Nigeria.
Thank you very much. And again, it's really lovely to be here and to be able to join you all in your speaker series. As you just mentioned, I've been working with Rocky Mountain Institute for 3 or 3.5 years, mainly focused on Nigeria and especially on rural electrification challenges in that country. And And just as a brief kind of caveat, I am working part-time with RMI now, so I don't want to be representing RMI in this question and answer, more just providing information on this really interesting project that has been established. So to get into the Undergrid Minigrid project at Mokoloki in Ogun State, I think we need to start with the challenges of rural electrification throughout much of the world, but it's a consistent challenge that we see in Nigeria as well. So we see that rural economies need electricity in order to develop. You can't grow businesses, you can't grow commerce. It's really pretty complicated to be part of the modern economy without reliable electricity service. And in much, especially of rural Nigeria, what we see is that the grid may not extend or the grid may not be reliable in those areas. And so often people are paying really exorbitant prices for power. If you look at personal generator use, like the Pass My Neighbor, those can cost on the order of US 50 cents per kilowatt hour, or upwards of 100, even up to 200 naira per kilowatt hour. We know that people are paying 200 naira per liter of electricity, in addition to the operation and maintenance costs of generators, in addition to the fact that those generators may not be reliable, or you may need a backup generator just to make sure that you have some reliability of electricity service. And that means that rural inhabitants are paying much more than their urban counterparts for electricity service. B, that service may still be less reliable when you think about issues with generators breaking down, or challenges with some residents of rural areas may not be able to afford a generator, and so they're relying on things like kerosene or batteries in order to just make it through their regular day. And so we see that there's a lot of systemic inefficiencies in these areas and challenges when you think about kind of reaching some of our sustainable development goals. So Rocky Mountain Institute became involved in this sector through collaboration with the Nigerian Rural Electrification Agency in trying to design some business models that would help to better serve these areas. And there's a couple of big challenges there. So first, you have areas of the country that are totally unserved. And that's a challenge, but it's surmountable. So you think about a place with no power lines, no connection at all to the utility or to the distribution company. And that's a challenge in that there's no service, but in terms of the regulatory structure, it's actually easier to address, because we see that off-grid solutions such as mini-grids or solar home systems, those can be provided, and there's really no challenge in who kind of has the right to serve that area. You could have a private mini-grid developer come in and build a system with really very few hurdles. The biggest challenge there is accessing the financing. And we've seen a number of those mini-grid systems be implemented in unserved parts of Nigeria. I think we're up to probably 20, 30, 40 at this point around the country, and those numbers are growing rapidly. The bigger challenge comes to what we call underserved areas. And those are parts of the country where there is grid infrastructure or distribution infrastructure. So you might see a transformer in the community, or you might see power lines overhead. And in some communities, there's power in those power lines, and it might be unreliable, or maybe not every household is able to connect. In some communities, there actually might just be a transformer with no connection at all. And the challenge in terms of electricity regulation is that even the presence of that transformer in the community means that community is kind of owned by the distribution company. The distribution company has the right to serve that community. And so for another service provider, they can't enter that community without a specific agreement in place with the distribution company. So again, those are what we call underserved or undergrid areas. We say they're undergrid because they might be under a power line, but they are underserved. And this is where the big challenge comes in, because we all know that distribution companies are really facing a lot of difficulties serving their entire service territories. They have huge areas, they have millions and millions of customers, and realistically, they may not have enough engineers to maintain the lines that far away from an urban center. They may not have access to enough generation resources. They might not be able to literally get enough energy to send to all of their territories. Or they might just have a limited amount of customer service capability, and so they can't effectively bill the customers out there, which again leads to delays in service provision and overall results in a financially unsustainable system. The Undergrid Minigrid that we're talking about is an example of a solution there. So in order to address these areas, Rocky Mountain Institute has been exploring the opportunity for collaboration among different players in the power sector. And especially in this type of situation, the distribution company, because they own the local infrastructure and they currently hold the right to serve the community. We have a mini-grid developer who could build, for example, a solar battery system to provide dedicated generation to that community. And then the community itself, which all of this discussion really needs to be centered around the community and the community's needs. And so first, Rocky Mountain Institute, about 2 years ago, conducted just kind of an analysis to understand the opportunity for sharing distribution resources and for serving these undergrid areas. Second, we did kind of a deep dive to understand what specific business models would make sense in Nigeria. So for example, in the Mokoloki project we'll discuss, the mini-grid developer actually owns the solar panels. And the mini-grid developer interfaces with customers, right? The mini-grid developer is the one billing customers, collecting payment from customers, setting the tariff. But that is not the only approach. And so there are other models, for example, a special purpose vehicle that would let the distribution company have a part stake in the project. Or you could think about a cooperative model where the community owns a part of the system. So there's a pretty wide range of different business models that you could think about using to implement this type of system. And then finally, and what we're all here to discuss is we implemented this pilot project in Mokoloki community. And this pilot project is, in my opinion, really a huge step in demonstrating that this type of approach and this type of collaboration within the power sector can work. We have seen a lot of movement across Nigeria and a lot of desire to implement this type of project and to have more distributed resources. So again, distributed energy resources, talking not about one coal plant that maybe serves a huge area, but having smaller pockets of distribution around the territory to provide local resources. There are several projects actually in Lagos, and I think one in Abuja, that use distributed resources to serve market areas. And that's a great first step. And the reason this project is actually goes a step farther is because we included the community. The community was a part of the negotiations. The community was a part of the discussion. And we're really centering the conversation here around making sure that underserved communities who are struggling financially, who might lack access to many resources that we think about as important for development outcomes, we're making sure that that rural community has access to what they need. So the pilot project, again, it was a collaboration between Ibadan Electric, Nio Tropical Technologies, who is the mini-grid developer, and Mokoloki community. So we worked very closely with the village leader in order to make it through negotiations. And largely those negotiations were about who owns the resources, right? So if you have a distribution company, Ibadan, that has been serving the community, they see that as part of their business. And we need to make sure that they actually see some financial benefit to this outcome. Similarly, the mini-grid developer, Niotech, we need to make sure that the mini-grid developer is profiting, because as a private entity, they can't survive if they're not making profit through these types of projects. And thirdly, the community also needs to benefit, right? We're not just trying to take money from the community. So it came down to a lot of very careful analysis to ensure that the community would pay less under this system than they had previously. And that's pretty important, because We don't want to be forcing resources on communities. We don't want to be forcing them to pay higher electricity bills. Really wanted this to be a collaboration that created a win-win-win outcome. And I think since the implementation of that project in February, so it's a solar battery mini grid system with a diesel backup system, a diesel generator, and it's serving about 300 residents and between 30 and 50 commercial enterprises. Since the project was implemented, we've seen increasing demand for electricity. We've heard from community members that they are able to run their businesses more effectively. And we've heard a desire from those project partners as well as others to scale this type of solution. So even On Electric is thinking about how can we do this in more areas? Niotech is asking, how can we partner with other distribution companies? And we've heard from some of our development partners like the German GIZ organization and the World Bank that they're interested in supporting Undergrid Minigrid projects going forward. So I think there's a lot of potential here for learning and continuing to develop the process along the way. I think with that, I will stop and maybe we can go into questions.
Yeah, perfect. Me personally, I have a question. Like in my community where I do stay for like 6 months now, we've not seen light in the grid line. I would say that's just, it should be used for a hanging wire. So I would like to ask, which role did the community actually play in the project?
Yeah, it's a really good question. And I think it's one that we can all think about as we move forward with additional projects, because as I mentioned, it really was integral to this project that the community was part. First, I mean, the community is the place where the project is being implemented. So they were wonderful hosts when we brought in representatives from the project developer, from the distribution company. They showed us what was happening. They shared really honestly the challenges that they were facing and what needs they had going forward. So they were very open in communication and in explaining, you know, what price for electricity could your community afford and what would be too expensive, and what kind of reliability of power do you really need to be successful. They also, I mean, the biggest financial contribution the community made was that they provided land for the project siting and distribution rights of way at an extraordinarily affordable price. And this is something that, especially for smaller mini-grid projects that only serve one rural community, it can be a real challenge to get land at an affordable rate, especially where the land is close enough to the community for the distribution to remain efficient. And so the community leaders were very generous actually with that. And third, the community, and something that actually was most critical to this project, is that the community worked together to identify how electricity could be productively used. And in the rural electrification sector, we talk about productive use as revenue generating uses of electricity. So for example, if I use electricity to turn on the lights in my house, it helps my quality of life, but it doesn't help me generate income. If I use the electricity to power a refrigerator and I sell cold drinks, that helps me to generate revenue. Or if I use the electricity to power a mill or a welding machine, that all helps me to generate income. And that does two things. One, it means I can pay my electricity bills. And two, it means that we have sufficient demand from the electricity system for it to be cost effective. So if you think about a community of 200 people, if everybody only uses lights, that's actually not enough consumption to sustain the system, because we have to pay, for example, the salary of the person who is providing support there. We need to have more payments coming in than just lights in order to maintain the system. So by making sure that we have many productive uses of electricity, that can help us to make sure the system is actually cost effective. And Mokoloki community did this in two ways. One, they supported their existing businesses in scaling up and in transitioning from generator usage to the grid electricity. And so, for example, we saw welders, we saw shop owners, we saw a hotel. They all transitioned to using the mini grid for power. We also saw new businesses being kind of courted to come in and set up shop in the community. So there's a soya drink manufacturer, there are some milling companies, like maize milling, and then there's an electric mobility company, so electric vehicles, electric motorcycles, and three-wheelers that are all interested in opening up new branches of their businesses in Mokoloki. And so again, that's making sure we have electricity consumption, but that's also helping the community grow and making sure that we have local jobs, and making sure that the economy is really starting to benefit from this new service.
So we go to the first Q&A section. So another question I have is this: how does the operator, that's the Niotropical technology, how do they deal with excess power? Because during the day, the sun is usually high, so there should be an excess power during the day. So how do they distribute the excess power? Do they transfer it to the grid?
That is a really great question. Today, they are not distributing excess power to the grid. Today, excess power is used to charge kind of an oversized battery bank to make sure that we don't have to rely on the diesel generator. And so the system during the day runs directly from solar power, and in the evening, we pull from the batteries that have been charged to power the community. The desire is that in the long run, we would see the mini grid interconnect with the grid and share power back and forth. And we didn't do that in this project for two reasons. One, it's just more complicated, and as a proof of concept, we really wanted to show that this business model was feasible before we added more levels of complexity to it. But two, in order to share power to the grid needs to be available. And so, for example, if the distribution company turns off a feeder, which is the reason power was unreliable in Mokoloki communities to start with, if they just turn off the whole feeder, the mini grid can't send power back into the grid because there's no power flowing in the lines. And that means that you couldn't rely on the main grid to offtake power. It would only be, maybe once a week when you had excess power that you were actually able to do that. And in terms of kind of the techno-economic modeling, it doesn't make sense from a financial perspective to pay for the cost of interconnecting and to go through the challenge of arranging kind of the contractual agreement. So how much will the grid pay for that excess power? Are you also going to purchase power from the grid? And if so, at what rate? Given how unreliable that power would actually be available, it just wasn't worth going through the negotiations at this point. I do think as we go forward, that will be kind of the key to this model being successful, because obviously we know the grid is operating at much higher scale. So power is generally cheaper from the main grid. And so we would like to see the mini grid and the grid kind of supplementing each other and sharing power back and forth. But it's just not something that's realistic at this point.
All right. So to the attendees, if you have any question, you can use the Q&A section to ask your question. So in your own opinion, what are the lessons and the challenges you learned from the Mokoleki project?
Yeah, there are quite a few. And we've written, Rocky Mountain Institute has written up several of these in the blog, I think, that I shared in some of the reports. So you can also look there for some of the more technical considerations. I think for me, honestly, one of the biggest lessons learned from my side was about this collaboration in itself. Before we started with this project, we talked to people, right, to get a sense of whether something like an Undergrid Minigrid would be possible. And every person we talked to, whether it was a representative of the government, whether it was a representative of the Minigrid Association, every person we talked to said, you know, you can't trust the distribution company because look at how their service has been. We can't trust them to be a reliable partner. And when we went and met with the distribution company, they were really eager to participate. They know that their service is not reliable. I mean, it's not like they're doing it on purpose. They know that their service is unreliable, and they are looking for new opportunities to improve on the situation. And so having just a little bit of trust and being willing to have the discussion with some of those partners, I think for us went a long way, rather than assuming that the distribution company would be, you know, unwilling, rather asking them up front. Some of the other lessons, honestly, they're not too exciting, but the process of negotiations took a lot longer than we anticipated because there are just so many little details. If you look at the NERC, the Regulatory Commission's mini-grid regulation, there's an entire section for interconnected mini-grids, and there are just a lot of details that need to be worked through. And so one opportunity we see there is, rather than negotiating that every time for every project, there's a window for a kind of standardized contract to be developed where, as a sector, we can kind of say, you know, this is what we value the use of distribution lines at. For example, just that fee that the mini-grid developer would pay the distribution company to share the lines. I think it took us 3 months to come to an agreement there because there's a question about, you know, what is that use worth? Is it the depreciation of the physical asset? Is that the value? Is the value the amount of revenue the distribution company would lose? Is it about the profit the distribution company would use? Is it about the revenue the mini-grid developer would gain? There's a lot of different ways you could kind of reasonably assign that value, and they all make sense. And so just kind of agreeing as a sector on what is reasonable and what is logical and what we're willing to accept, I think could really help going forward.
So I have a question from Victor. What are the distinct or peculiarities of the undergrid mini-grid to the normal mini-grid that we have in Nigeria?
Yeah, that's a great question, Victor. There are a few. The first one is honestly just that it's in a community served by the distribution company. So like I already mentioned, that means you need to involve the distribution company in project planning and negotiations, which is not the case for a standard mini-grid. And you might think, you know, that just sounds like a lot more work. Why would I do that as a developer? Why wouldn't you just build a mini-grid in an unserved area with no distribution company presence? And the reason for that is that if you think about a distribution company network, most likely the network is kind of centered on a large city. So Ibadan, right? The Ibadan distribution company's network is centered on Ibadan, and it radiates out from there. That means communities that are closer to the center, closer to Ibadan, are likely bigger communities. They likely have more economic activity because they're trading with the city. And the farther out you get from that city center, the less activity you see. And as a result, I mean, if you're seeing less economic activity, it means rather than businessmen, we're probably seeing families that are involved in agriculture or families that are running very, very small community businesses. And those families have less ability to pay for power because they have less income. So realistically, if you get far enough out of the city that the distribution company is not serving the community, so it's an unserved community where you can build a mini grid anywhere you want, those customers are probably pretty poor and they have limited ability to pay for power. And that means as a mini grid developer, you have less profit potential than if you're working with a community where there's more going on. So if you work in an undergrid community where there is some grid access, it poses negotiation challenges, but the community is likely larger. It likely has more economic activity, more ability to pay for power, and probably customers, because they have had grid service before, they probably own more electric appliances. And so, like I was saying before, in a very rural area, maybe people only have a light that they're going to connect to the grid. But if you're working in a community that has experienced grid power before, they probably own lights, but they probably also own televisions. They probably also own fans. They probably also own refrigerators. And so there's going to be a lot more demand for your service there. And that's actually the main balance, the main trade-off we think about between unserved and underserved communities is the challenge of implementing a project versus really the demand for power and the likelihood that your system can be financially viable.
That's a good answer to the question. We have another one from Winner Godson. When the project started, how did ROMI start the conversation with the government, and what were those conversations like?
Yeah, I'm really glad you asked, Winner. Rocky Mountain Institute as an organization only works in geographies where it has been kind of invited in to participate. And so we began working in Nigeria 5 or so years ago because there was an invitation from the Rural Electrification Agency, which is part of the Federal Ministry of Power, to come and support off-grid sector development. So we were invited in specifically to help think about mini grids and other mechanisms for serving those rural areas. That was helpful in that we had a relationship with the government already because we were in discussion with the Rural Electrification Agency. And many of those were actually pretty interesting. When you think about an agency sitting in Abuja asking, how can we support rural electrification? There's some discontinuity there, right? I mean, if you're sitting in Abuja, you probably have power 24 hours a day, if not 24, maybe 23. You probably have access to a lot of services. You probably have access to all of the different types of goods you need. So it can be a little bit challenging to think about across the country, what is the scope and the scale of challenges we're discussing? And that was actually where we started, was to see what is the magnitude of need? So how many people are we talking about? How many communities? And it turns out we're talking about, tens of millions of people and tens of thousands of communities probably. And beyond that, the question the government wanted to ask was, how can we realistically pay for that type of work? So if you think about, as a government, you need to provide electricity access to tens of millions of people. That's a lot of investment in power lines and in power stations and in expanding the capacity of the distribution companies and customer service and making sure that rural customers know how to use electricity effectively. And that's often beyond scope of an individual government. So part of the question there is, where is there an opportunity for investment, right? Is this a private sector project where we can get investors who can see a return on their investment if they help start a mini grid system, for example? Can mini grid systems be profitable enough to attract that private investment? If not that, where are there opportunities for financing, for example, through the World Bank? Are there places where we can access that type of capital? If not that, where might there be grant opportunities? For example, through GIZ, is there a partner who will be willing to donate some funds to get those projects started up? And I don't mean to focus too much on the finances here because I know that's not the most interesting part of these projects, but honestly, in a place like Nigeria, you have the customers, you have, for example, the solar resource if you want to be building solar systems. And so a lot of times the biggest question is who's going to pay for it? And that was, I think for us, that was how a lot of the conversations with the government started. And from there, it was about, how do we know it can work? How do we get proof of concepts? Can we get pilot projects on the ground? And how do we make sure the sector stays kind of connected? How do we make sure that information is being shared so that, all boats rise rather than having so much competition that it might be harmful?
I saw your post about India trying to adopt the Minigrid the Undergrid Minigrid, sorry. So
Mhm.
are they going with the same model of the Nigerian one? Same business model?
They actually are not. India is really an interesting place to work. So Promises is describing a new article that we just put out talking about the applicability of this model to India and other emerging economies that are still trying to achieve 100% electrification. In India, it's really interesting because they, over the last 5 or so years, their government has been very insistent on reaching universal electrification. And so they expanded the grid. I think every community in India is connected to the main grid. And the problem is not every household and every community is connected to the main grid. And you still have these reliability challenges where even if your community is connected, maybe 10 hours a day you see power, but the other 14 hours, there's nothing. And so those numbers are important because of the question you asked earlier around sharing power back and forth with the grid. So in India, they likely would not have an undergrid minigrid that was isolated or islanded from the main grid. If they used undergrid minigrids, they would set them up from the beginning to purchase power from the grid and to sell power back to the grid. And they would use it as an additional generation source and a way to ensure reliability. And that's just because the general reliability of the main grid is a little bit better, and it's more about the infrastructure needs for the last mile access.
All right. We have another question. I think I love this question. How did you get to where you are now in your career? How can other youths interested in this topic get involved?
That is also a great question. I'm not too far in my career. I'm 30. So I've been out of grad school for just over 5 years. And for me, I think there were, well, I'll describe how I got here, and then we can think about what other, what you might think about to get involved in this type of work. So for me, I did my bachelor's degree in the US and I studied physics. I received my master's degree also in the US in natural resources and the environment with a focus in energy systems planning. And I spent some time abroad as a US Peace Corps volunteer, which is one of our national volunteer opportunities where you spend 2 or 3 years in another country assisting a community in whatever way they need. So I was a mathematics teacher at a secondary school in Namibia, which is next to South Africa. And I think that was actually, for me, American, talking about the Nigerian economy, that was important for me because many Americans without that exposure find it really challenging to work in other countries. As I think it might be the case that many Nigerians who don't have international exposure might find it challenging to work in the US. So for me, that was one way that I started working in foreign contexts. And from that, a lot of my work in India and Africa kind of evolved. One thing that was really helpful for me was that during my master's degree, my thesis was focused on mini grids. And specifically mini-grid projects in rural India. And so, again, India and Nigeria, pretty different places.
Yeah.
But the fact was that I got deep enough subject matter expertise in understanding what are mini grids, how do mini grids operate, why would you use a mini grid instead of a different type of system? And that all transferred to Nigeria. And so when I applied for this position with Rocky Mountain Institute, it was pretty, I think I was able to make a good case that I was interested in this work. I had a history of working in this sector, and I could already demonstrate some of the specific skills that it takes to work in that context, to understand the landscape, and to make that type of project succeed. So I think for me, that is one of the biggest pieces of advice, is to get hired in a specific type of work, whether you're interested in local engineering projects, whether you're interested in specifically, electricity distribution, whether you're interested in this off-grid type work, you need to be able to demonstrate that you know what you're talking about. And so any type of volunteer project, any type of student research that you can do in that area will be really, really helpful, and just kind of having something to point to for a future employer, saying, look, I cared so much about this work that I already got involved. And here's what I already know. You won't have to teach me everything starting from ground zero. I don't know if that totally answered the question. I'm not sure if anybody wants to follow up there.
So any other question from the attendees? So this project is really dear to my heart because my community, we've not had life for like 6 months. So before I let you go, I would like to ask, moving forward, do you see the adoption of Undergrid Minigrid? Do you see other projects like this developing in Nigeria?
I do. I see this project as a critical first step in demonstrating that it's possible. I think a lot of folks in the energy sector, especially, if you have ever worked with older engineers, many of them know how to solve problems, but they might know how to solve problems in one way. And if it's been working like that for the last 30 years, they might ask, why would I do it differently? I think this project was really important in showing that there are other approaches to providing electricity service and that they can be successful. We've heard at Rocky Mountain Institute from a number of individuals, both from the government, from the on-grid kind of utility side, and from the private sector, thinking about, we'd like to see more of these projects integrated. What recommendations do you have? Or indicating that they're interested in also developing similar projects. So again, I think now that there's evidence that it can be successful, yes, we will see more implementation of these types of projects. And I think there's a great opportunity there for citizens to pressure their utilities to say, or their distribution companies to say, we know there are ways that you can provide reliable service. Here's an example. Can our community work with you to establish a new type of model? And maybe that would be one way to get something started.
I hope my community start the process of pressuring the distribution company in my community. Then I have another question from Winner. I guess you've answered this, but let me read it out. What were some challenges you had working on the Mokoloki project?
Yeah, a lot of them were logistical and pretty boring. Like the fact that Rocky Mountain Institute is based in the US makes it hard to support negotiations quickly in another country. And that really has nothing to do with anything other than Rocky Mountain Institute has yet to open its office in Nigeria. I think the more relevant challenges there are, one, I mentioned how long it took to get through negotiations. And realistically, that's a hassle from the utility or from the developer side. That's a huge downside for the community when, Promise, you just said your community hasn't had power for 6 months. If you think about negotiations that take 6 months versus 1 year versus 2 years, that's really influential on how your and how you are able to continue the type of work you want to do in your community. So that negotiation process is pretty important. I think another challenge was, and this gets kind of to your question about how would I engage the distribution company on something like this? Like all companies, distribution companies are hierarchical. And so you might start by talking to somebody who oversees service to that community. And that is one place where we started, was working with the local engineer who is responsible for service to the area around Mokuloki community. But by the time you get that engineer convinced, then they probably have to raise the issue to their supervisor. And that supervisor might have to raise the issue to their manager. And their manager might have to raise the issue to somebody else. And so it can actually just be very time consuming internally to make sure that all of the right individuals within the company are on board. I don't know that I have a solution for that one, because I think companies all around the world, that's how that works. But it is certainly a challenge in the sense of time management.
All right. Any other question before we close the section? So for feedback and queries, you can contact us at futo@studentsenergy.org. I want to say a big thank you to the attendees and specifically to Sachiko for your time. Thank you very much. I hope next time we'll call on you, you will make out time to speak with us.
Absolutely, just let me know.
Thank you very much. Have a lovely day.
You too, bye-bye.
All right.